Hello everyone, welcome to my class today. So on today's class, we are going to be solving the problem under probability. But before I proceed, I want to explain something in probability that relates to the problem we are solving here today. So um, we have what is called the random experiments in probability. Unlike the usual experiments we all know of in physics, chemistry, and the rest of that, the random experiment in probability is different. Now, before now, we have known that experiments are supposed to be such that when they are performed under certain conditions, similar conditions are supposed to produce certain expected value. But in a random experiment, it is not so. A random experiment is an experiment that when it is carried out under similar conditions repeatedly, it would give us several unexpected outcomes. So that is what we are going to be looking at this on in this class. So an example of such an experiment is an experiment with regards to the throw of a coin, an experiment with regards to the throw of a die, but the one we have on the board is that with respect to the throw of a coin. Now let's go as we solve together. Solution. So the question says that in a single throw of three fair coins, we have three coins. Remember, a coin has a head and a tail. So when we throw it, there are possibilities that the head will come up or a tail will come up. So when we have the three of them and then we throw them, that is a random experiment. So the first thing we do when we are solving problems in probability like this, we generate what is called the sample space. A sample space is a collection of possible outcomes with respect to that particular experiment. So we are going to be generating the possible set of values or the possible set of outcomes with respect to the throw of three coins. So let's do that. So this is our sample space. We'll use a capital letter S to represent it. So when we throw three coins together, there are possibility that we will have three heads coming up. There are also possibilities that we will have head, head, tail. There's a possibility that we'll have head, tail, tail. There's a possibility that we'll have head, tail, tail, tail. There's a possibility that we'll have tail, head, head. There's a possibility that we'll have tail, tail, head, tail. There's a possibility that we would have head, tail, head. There are supposed to be 6 points. 1, 2, 3, 4, 5. Sorry, 8 points. 1, 2, 3, 4, 5, 6, 7. 1 point is still remaining. So we are supposed to 1 point is remaining. Head, tail, 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 head, tail, head, head, tail. Okay, we are supposed to have tail, tail, head. I think that's the point that is missing. How do we determine that? We use 2 raised to the power of n. 2 here has to do with the number of sides on the coin, and then the n here has to do with the number of throws, which is 3. So 2 raised to the power of 3 is 8. So this is why we have 8 sample points in our sample space. So we go ahead now to answer the question. So question 1 now says that we should find the probability that 1 head, 2 tail appears. Now, typically, a probability can be defined as a fraction where the numerator has to do with the number of possible events the number of possibilities or possible cases with respect to an event, and then the denominator has to do with the total number of possible cases with respect to the entire experiment. So we have what is called the event, we have what is called the possible outcomes, that is a sample space. So number one here has to do with an event, and the event is concerned with one head, two tail. So where do we have one head and two tail? One head, two tail. We have here one, we have here two, one head, two tail, three. So this is going to be 3 all over 8. That is, let me write it formally, the probability of E1. E1 here represents the event one head, two tail is equal to 3 all over 8. Now, this is number 1. Number 2, the probability of E2. E2 here represents the event two heads, one tail appearing. So wherever we have two heads and one tail, we will count 1, 2, 3. There are also 3 of them. So this will be equal to 3 all over the possible number of cases, which is 8. And then number 3 here, they said the probability that at least one head appears. So we could have more than one head appearing. So there's more than one head here. At least one head. That is, we must have a head in that event. So there are heads here 1, there are heads here 2, there's a head here 3, there's no head here, so we'll not count it. There are heads here 4, there's a head here 5, there are heads here 6, and there's a head here 7. So the probability of the event E3, where E3 is representing the event that at least one head appears, is equal to 7 all over 8. And then question 4 says that the probability that no head appears, we call it E4. So E4 here represents that the event that a head does not appear at all. So when we look around, there are heads here, there are heads here, there's a head here. I think it's just 1 point where we have the tail. So it's going to be 1 all over 8. So clearly we can see on the board that we have 4 different possibility, chances, or probability, as the case may be, for the 4 different questions they have asked us regarding the random experiment of 3 throw of a coin, or the throw of 3 coins, whichever way you want to express it or understand it. I hope you enjoyed the class. See you in the next video. Do not forget to like, follow, and share. Bye bye.